So the basic function for a parabola is y equals x squared. X squared. Okay, and what that looks like is this. Here's a sketch. It starts at 0, 0, and if I move one position to the right, I need to move one up. 2 positions to the right, I need to move 4 up. 1 to the left, 1 up, 2 to the left, 4 up. Okay, that's supposed to be a smooth curve. It's not. Your one will be a much nicer one. Just for a moment, if I compare that with this line here, y equals x. Okay, y equals x, you should know, is a straight line that looks like that. So that's the basic linear graph. This is the basic parabola. Now, let's say, for instance, you weren't aware that that's the basic parabola. Remember, we could go back to our old technique of giving ourselves a few x values. Okay, so I'll stick with the traditional -2, -1, 0, 1 and 2. And remember, y is equal to x squared. So over here, -2 squared is, -1 squared is, -1 squared is 1, 0 squared is 0, 1 and 4. Notice that these coordinates, -2, 4, are the coordinates that I drew over here. -2, 4, -1, 1, is that one? 0, 0, 1, 1, and 2, 4. Hence the basic parabola. So you could always fall back on that method. Like when we did x plus 1, we remember how the graph shifted up 1? That's what happens when you put plus 1. Remember this, Christy? It's the same as if I did x squared plus 1, the whole graph shifts up 1. Or if I did x squared minus 3, say, what's going to happen now? The whole parabola will move 3 positions down to here. The way I draw these conventional parabolas is I think to myself, across 1, up 1, across 2, up 4. If I went across 3, how high would I go? Across 3, up. I'll start again. Across 1, up 1, across 2, up 4, across 3, up 9, because it's x squared, right? Across 1, up 1, across 2, up 4, and across 3, starting from here, back 3, up 9. Okay, so that's how we shift a parabola down 3 positions. This time I'm going to shift the parabola to the right. Okay, so the new parabola is going to look like this. I've shifted it to the right. The equation for this looks like this. Y equals How far to the right shall I shift it? 3 positions? It's counterintuitive. That's what it looks like. -3, and I haven't made a mistake there. It is -3 shifts it to the right. How do you think I might shift a parabola to the left? Plus instead of a minus. Great. So here's my axes. Okay, that's on the x-axis. Equals x plus, say, 2. And then that for that position would be 2. This position would be 3. Okay, so what I've covered so far is how to shift a parabola up, how to shift a parabola down, and how to shift it to the right, and how to shift it to the left. All good so far? This is all written in about page 106 or 107 of the textbook, so you could copy it down from there. My next shift is going to be how to flip the parabola upside down. Anyone want to take a guess at how I might do that? Minus squared? Minus x squared? Okay, if you refer, this is the line y equals minus x. Remember, that's that line there. And what that is it's the line y equals x reflected in the x-axis. You see that? If you put a mirror line along the x-axis, you would end up with y equals minus x. Well, the same is true for a parabola. If you take y equals x squared, put a minus in front of it, okay, that's flipped in the x-axis. Okay, so that's how you can flip a parabola. By the way, this one is still the standard one. Across 1, oops, up 1, across 1, up 1, across 2, up 4, or down 4 rather. So I've done left, right, up and down, and flip things. What other movements are there left to do? Flatter or narrower. Okay, so we call that amplitude. Now I'm not going to tell you which does which. I'm going to get you to use your graphics calculator, and I'll show you, or if you could borrow a graphics calculator, you can figure this one out. But basically, you have a number in front of the x squared, and if I draw the dotted line one, right, the dotted line one represents the standard parabola with a equal to 1. If I wanted to make the parabola wider, like this, what's a going to equal? Have a guess. Is it a number bigger than 1 or a number smaller than 1? It's actually smaller. You can play around with this on your calculator. has to be less than 1. If you want the parabola to be narrower, a has to be bigger than 1. With your graphics calculator, to prove this to yourself, you need to go menu and the graph mode. It already reads y equals. All you have to do is put an X. Now the tricky bit, or the bit that people get mixed up, is that's the X button there, the one I'm pointing to. So you push X, comes up with an X there, and then you push squared, right? So y equals x squared, and then you can hit execute, then you can hit draw, and that's your basic parabola. Notice it goes across 1, up 1, across 2, up 1, 2, 3. It's off the scale. Well, if you click this button here, actually shift F3, you can change the scale so you can see further up the graph. If I look at the Y scale, the max, I want it to be bigger than 4. So I'm going to change that number there and make it 5. Okay. Now it goes up to 5. 1, 2, 3, 4, 5. And that plot there, in fact, you can go shift trace if you like. So, -2, 4. That plot there is on the curve. Zero, 0 is on the curve, and 1, 1 is on the curve, and so is 2, 4. Okay, I want you, if you have a graphics calculator, to experiment by, say, choosing 2x squared, see what happens, hit execute. Also try, say, 0.5x squared, and see if you can identify what's actually happening.